So, load testing in production. What does that sound like to you? In my experience, the responses to the suggestion of load testing in production are very likely to fall into one of three buckets, depending on your experience, on your work environment, and maybe your personal inclinations. The first one, and this tends to be a small minority, although I do believe that the numbers will grow, will be like, yep, that's a great idea. Definitely sounds great. In fact, we're already doing it. Been there, done that, got the t-shirt. This talk is probably not for those people, although I would love to talk to you about your experiences. Those people are probably not even in this talk. They're probably off already, having Friday cocktails. And they might even deploy at 4 p.m. on the same day into production while sipping their cocktails, because that's the kind of confidence that load testing in production can give you. The second group, perhaps bigger than the first one, will probably be like, nope, just no way, cannot do it, stupidest, most reckless idea ever. And those people may have very valid legal or compliance reasons. Sometimes those do exist, which mean that you cannot run production load tests. But more frequently than not, those people are just hardcore skeptics. And that's okay. This talk is not really for those people either. All I would say to them is, what are you so worried about? Is your production system really that fragile that it cannot handle any extra traffic? You should lean into your fear and not run away from it. Finally, the third group, which is by far the largest, is people who have a mixed reaction to the suggestion. So, load testing in production, it sounds interesting, it sounds valuable, but it also sounds quite risky and quite dangerous, which probably sort of makes it even more exciting. But, even if I understand the value of doing production load testing, how can I actually do it safely? And how can I show to other teams and other departments in the company that it can be done safely? And how do we go about it? So this group of people is the audience for this talk. And you might be a developer, you might be a test engineer, you might be an SRE. It doesn't really matter. This talk does not presume any particular deep knowledge in any one of those specific areas. Load testing and production in general is a team sport. And I'm going to give away the good stuff straight away. Yes, it is very possible to run load tests in production and do it safely. And all the stuff that I'm going to share here is not magic. It's not rocket science or rocket surgery. It's not some weird arcane knowledge. It's all pretty straightforward stuff. Some of it may require slight perspective shift and the ability to communicate the purpose of the whole exercise or enterprise to other teams in the organization, but it can be done. And most importantly, my goal with this talk is to give you a high-level roadmap for getting there. The goal here is to help you go from absolutely zero extra load in production to running significant load testing in production, and to give you a mental checklist of stuff that you can use to make sure that this process is as straightforward as possible, and that you will not forget something important and mess something up in production. So as is part of the course, a few words about myself. Who am I? I am a software engineer turned SRE. I am an open source developer. I'm very passionate about developer tooling and building things that enable developers to do things better and do things faster. And most importantly, for the purposes of this talk, I have helped a few companies over the past couple of years implement production load testing in their systems. A couple of those were e-commerce companies. One was a live streaming platform. Another one is a big international publisher. So the experiences are based on companies in a variety of different industries, companies that organize themselves and their work differently and how they run their production systems. But the process itself is pretty much the same everywhere. So why do we want to load test in production? As engineers with experience of working on complex systems, we tend to have an intuitive understanding for what the value is and why it's important, and in general don't need to be convinced. but it can still be very useful to be able to articulate those reasons, both for ourselves and also for others who might have worries and concerns. So I'll start with something sort of flippant and turn that question around and say, instead of asking why, ask why not. Really, it's if nothing else, running production load tests is very, very exciting, and it's important to have fun at work. Well, if we go back to being a bit more serious, the number one reason for running production load tests is gaining extra confidence. And it really is as simple as that. That is the reason that we do any kind of testing, of course, from unit tests to integration tests to security tests, etc., etc. If we imagine a spectrum of confidence, and on one side you have absolutely zero confidence that anything will work, and then on the other side you have 100% confidence that everything will work perfectly at all times, which of course is an unattainable ideal. But anything that helps us move from left to the right is very, very valuable in general, and we want to get as close to that 100% as possible, even if it's unattainable. And what I always say is that the kind of confidence that you get from running production load tests is really, it cannot be matched by any other kind of testing. It really is amazing. There is a real shift once you've run your first production load test, provided that you didn't cause an outage, of course, that it just feels good. You know that stuff works. And also stuff that's very hard to test otherwise. Things like CDN configurations, auto-scaling configurations, auto-healing, circuit breakers, back off and retry mechanisms, logging, monitoring, all of that stuff. You know that it just works, and it works beautifully together, like an amazing symphony. Running production load tests is very clear, almost binary proof that things are running as they really should be. To step back a little bit, the underlying reason is, of course, complexity. Running production systems at scale is very, very hard, and it's not getting any easier. And there are two main reasons for that. The first one is architectural complexity, which of course tends to be there for a reason. Any production system will do a lot of different stuff, and that can manifest itself as microservice-based architectures, a mixture of modern and legacy stacks and components, capabilities to support operations like auto-scaling and auto-healing. They're very useful, but they can also increase the complexity of your architecture, things like failover components, and many other things. The second reason is the rate of change that we're seeing in modern complex production systems. So CI/CD is pretty much table stakes these days. So that means that if I'm on a development team and we are responsible for a number of microservices, we'll probably be deploying to production multiple times a day. And it's not going to be just us, it's also going to be other teams in the company who will be deploying to production multiple times a day. And then any services that their services depend on, as well as third-party dependencies. And it's not just code changes either. It's configuration changes too, and infrastructure changes as well. So with all this change going on, it's pretty much impossible to keep up to date with that. And change equals risk, which we always want to mitigate. But when it comes to the performance of a system, performance in a complex system is always going to be an emergent property that will arise from interactions between components. And it is a property that has a direct relationship to the immediate environment that your system runs in. So, down to the type of EC2 instance that your stuff actually runs on, your resource configurations for containers running on Kubernetes or ECS, ingress controller configuration, load balancer, all of that stuff. You cannot decouple those from your application code, which means that load tests are fundamentally different type of tests from unit tests or integration tests, which test more abstract logic and interfaces. And the bottom line here is that the only way to get guarantees about the performance of a complex system is to test that very system, which means that you need to load test in production. We're of course seeing the recognition of these facts in popularity of techniques such as chaos testing. That is exactly the reason that as an industry we're embracing that. It's impossible to predict how exactly a system will fail sort of analytically. We need to run experiments and we need to see what happens. And it's also the reason for why observability has become such an important subject. We really have to be able to inspect our systems as they're running and to be able to peek into them when they surprise us in production. It's all to do with that complexity and with those rates of change. And production load testing is a great way for identifying all kinds of unknowns in your system. It's also a great fitness function, speaking in evolutionary architecture terms. So it's a great book. If you haven't heard of it, I would definitely recommend that you read it. So a fitness function is something you can proactively and also very visibly enforce certain desirable properties in your system. And with production load tests, it's of course performance-related properties. Production load testing is also a great guardrail for your top-line SLOs and KPIs. In practical terms, what it means is that just because your system could handle its usual daily traffic peak yesterday, it doesn't mean that it's going to be able to do it today. And if you're expecting a high traffic event coming up, the only way to be able to say that, yes, we'll definitely be able to handle it with a high degree of confidence is to actually test it. You don't want real users to do it for you, and you definitely don't want to hope that things will be okay. And finally, the ability itself to run load tests in production is a signal, and a very good signal, of a high quality bar, both technical and organizational. As I said, production load testing is a team sport, so the ability to run those production load tests means that different functions and departments in the company can self-organize and work together effectively. If you start doing production load testing, you will be in very good company. So these are just some of the companies that have spoken in public about their production load testing practices. I personally believe that it will become an accepted best practice over the next couple of years, simply because of how valuable it is and because of the wider trends that I mentioned. And perhaps your team could be at the forefront of that. So we'll look at some fundamentals and establish some base ground in the next chapter of this talk. So there are three main types of production load tests that we can encounter, and those are traffic replay and amplification tests, adding synthetic traffic from virtual users to your production system, and then also something that is frequently known as dark traffic testing. And you can, of course, mix and match between those three, depending on the exact nature of your system and what you're testing. So traffic and replay amplification, as the name suggests, means that you capture some production traffic and then you replay it, perhaps with an amplification factor, back into production. This tends to work well for systems which respond to or process kind of isolated requests, stateless systems with no dependencies between multiple requests from the same client. So for a website, a classic example would be a news website, which doesn't have very much personalization, or a classifieds website. For an API, it could be an event ingestion endpoint, which just receives some JSON blobs, again, with no dependencies between different events. So this is a very powerful way to run production load tests, and also probably the easiest one to get started with, because you're kind of replaying traffic. There isn't really that much else to do there. There are some obvious caveats here. Basically, you don't want to create a runaway loop, which is just infinitely feeding itself and eventually blows everything up. The way you avoid that is by being able to distinguish real traffic from replay traffic at the capture point, and then having some intelligence in the traffic replay layer to make sure that you do not exceed a certain threshold of extra traffic above real traffic in production. Then for systems which expose some kind of a transactional interface, that is systems where you have multiple requests from the same client, but they depend on each other in some way. For those systems, you're probably not going to be replaying traffic for obvious reasons. An example of such system can be something as simple as an API endpoint, which requires authentication first. So you authenticate and then you include a token in every subsequent request. In terms of a website, you can imagine a CMS being one of those systems, or a classic example is an online store where a user arrives to it, they run a search based on some keywords, they browse through some of the results, products go into a cart, and then eventually they go through a checkout process. Essentially, this is anything with some kind of a session. And for these systems, what you want to do is you write your definitions of common user journeys and scenarios, you parameterize them and randomize them, and then you run them against production. It's important to say here that these two types of load testing are not specific to production. This is how you would also test an isolated component, for example, in a non-prod environment. So dark traffic testing is also very interesting, and it can work really, really well for certain use cases. Essentially what it means is if you're launching a new component into an existing production system, you can deploy it alongside everything else that's already running and then send real traffic to it, but without exposing it to real users or without including it on any kind of a critical path for any existing functionality. An example would be a new event logging endpoint, which is hit on every page load on a website, but which is completely decoupled from everything else otherwise, so that if it goes down, users don't notice. But the team that runs that service is essentially using real traffic to load test this new component. It works really well when it works, but obviously that is not something that you can do on a whole production system. So for the purposes of this talk, for the rest of it, we'll really focus on the first two types of those tests. To run load tests anywhere, you obviously need a way to generate load. There's loads of tooling out there, and you may already be using something. What you go with specifically will really depend on what you're already familiar with, what's already available, and many other factors. Some tools will make things easier than others, but ultimately it's a choice that will need to be made by every team individually. I'm not going to give any specific recommendations here, but I'm going to outline a list of requirements that you can use for evaluating different load testing solutions for production load testing. So first, can you actually run production-like workloads with whatever tool you're looking at? The tooling needs to support creating complex scenarios with dependent steps. It needs to support parameterization and adding fake but realistic looking data into your tests. It should support being able to weigh different scenarios and to be able to generate varying load patterns, with different ways to ramp up and ramp down load. So essentially, you need to be able to express realistic user behavior with whatever tool you end up choosing. Second, very important, how easy is it to run distributed tests? To run a load test in a production system, you will probably need to generate a lot of traffic. So can you run your load test from 100 nodes, for example? Third, you will need to be able to generate traffic from different geographical regions. So these days, it usually means at least two different regions, whether it's EU West and EU Central, or US East and US West. This will depend on what you're testing, of course. If you've got clients across the world in America, Europe, and Asia Pacific, then you will need to be able to generate load from all of those regions. Extremely important is real-time reporting from your load tests. You really need to be able to see response times and response codes that your load generator is seeing as the test is running. So this means not just graphical reports or reports on the terminal as the test is running. There must absolutely be integration with your existing monitoring setup, whatever that is, whether it's Prometheus, Datadog, CloudWatch, or something else. You really need to be able to see your metrics, all of your metrics from everywhere alongside each other. And then finally, you will be testing a production system. You'll be generating a lot of load. You'll need to be able to do it without breaking the bank. This kind of rolls out a lot of, if not all, hosted software as a service solutions. and generally points you towards something that you can run on premise. If you want to run these tests regularly as well, and not just once a year, then you definitely want to be able to run them cost effectively. And finally, you should be able to extend and customize your virtual user behavior pretty much in an unlimited way. You should be able to send custom metrics. You should be able to run custom assertions on responses, constructing requests on the fly based on some external parameters. And the reason for that is, again, complexity of a typical production system. More often than not, you really need to do something that load generator doesn't do out of the box. So if you can script it, that really helps. And this is more of an advanced feature, but if you can either get something off the shelf or build something that lets you change the level of load dynamically, then you can do some really, really cool stuff with your load tests. Like, for example, automate back-off behavior later down the line to make your load tests kind of ease off or even completely stop when response times experienced by real users start going up. Okay, so usually, if we look at production load testing, there are two main motivations that teams will have for wanting to run production load tests. The first one is very typical. It's some kind of a big traffic event coming up. So an example right now would be Cyber Week, if you're in e-commerce, with Black Friday and Cyber Monday coming up and general holiday season. Last week, it was election week in the States. If you're a publisher of some kind, it would be something like London Fashion Week for Vogue. You get the idea. Maybe Scale Summit if you're Twitch. So in general, you would have projections of some traffic that you're expecting, and you will want to make sure that you can meet it. A launch of a new service would fall under this category as well. The second typical motivation is to be able to build some kind of a margin of confidence or safety into your existing production system. So a good goal to aim for in general would be something like, we want to run 25% of extra load in production at all times, which means that we can absorb an extra spike of that much traffic at any point without breaking a sweat. And there is a couple of different ways that you can kind of look at it or implement it. You could run a test like that on a schedule, for example, just weekly with extra load being added above your natural weekly peak. Or you can run it continuously, which is a more advanced use case as a percentage of real load or some kind of a fixed margin above your weekly peak. And of course, it's very natural to shift between those two. So if you start by preparing for a high traffic event, you'll have all of your test definitions and all of your infrastructure in place to then start running those tests on some kind of a schedule. With eventually maybe automating that to run with absolutely no human oversight. So this brings me to some general principles which underpin production load testing. And the first one is that you will be building up your production load testing capacity in iterations and layers. So that graphic on the side of that slide is just one of my favorites. It's from a talk about how Spotify build products, and it's just a really great demonstration of the mindset that is, I think, the best mindset for building any kind of a new software system. So you start with building something that is small but useful, and you build up from there. In practical terms, for our purposes, it means that it's absolutely fine, for example, to start with a production load test, which runs just once a week by a human following a simple runbook with very little or almost no automation, testing just one user journey. That's a great place to start. Whatever you build or you end up building, it doesn't have to do everything from day one. The second important principle is that it will take time. It will take quite a bit of time to put everything together and to build up capacity to run large-scale production load tests safely and to address everyone's concerns, which is very, very important. So realistically, you should be planning at least a couple of months for different conversations to be had, for different teams to be able to allocate time to gather any data that you might need, to put extra monitoring in place, to make changes to some of the services to accommodate these production load tests, and to just get comfortable with the idea. It doesn't mean that nothing will happen for a couple of months. No, you should be able to start adding some extra traffic to production within a couple of weeks, but you will not run a big production load test for a while. It cannot be a last minute effort. It really does take some time. And the third one, and this one is possibly the most important one, and really understanding this principle can clear up pretty much every single objection that people generally throw up in response to someone suggesting production load testing. And that is that you will need to instrument your code for load testing and add some load testing specific code. It's not as weird as it may sound. We already add extra code to our code bases to do things like monitoring, logging, feature flags, A/B testing, you name it, security controls. So adding code to help us load test is just one more of those. And we can look at some examples of common objections which are addressed by extra instrumentation in this section. So in my experience, this is a pretty exhaustive list of the objections or concerns that come up when you start discussing production load testing. So the first one is, so there's several things thrown together there, but it can be summarized as, what about extra records or junk in the database? What about extra logging? Yes, synthetic traffic in production is going to add extra database records to your production database. It is going to make your code send out more logs and send out more metrics. Your traffic dashboards will show that extra traffic. It will affect analytics. It will affect all kinds of reports assembled by other teams, such as a marketing team or a data team or an advertising team. And this is, as I said, exactly where instrumentation comes in. So in practical terms, you will need a way to distinguish real traffic from synthetic traffic, possibly as it propagates through the entire system as well. So for example, if service A is the entry point into the system and it calls service B, then service B will need to be able to know when a request that it receives from service A was initiated by a load test. One common way of doing this is through an extra HTTP header, which is then propagated across every subsequent request inside the system. And that's exactly the same mechanism that makes distributed request tracing work. So not rocket science. You will also need a way to distinguish any persistent objects or any database records which are created by load test traffic. Because, for example, you might want to clear them out periodically, or you will want to be able to ignore those objects or database records for reports created by your data or your analytics team, for example. One simple way to do it, as an example, is to use a convention for usernames or user emails associated with accounts, and you can do that by the main part of it or username part of it, or a combination of both, perhaps. You can get quite creative here, but in general, a solution is there. So the third one is, what do we do about irreversible or destructive operations when we run production load tests? And those are basically operations that you really don't want to trigger from synthetic tests. A classic example is attempting to charge a credit card or send out an email. And what you will need to do for these, this again ties back to instrumenting our code, is to add no-op branches to your code base. So if a request is from a virtual user, do not charge or do not try to charge a credit card, or maybe call a mock. It will take time to discover and identify those places in a system and then implement that branching, which is why you need to kind of allocate for plenty of time for production load testing preparation, as I mentioned. And then another obvious concern, of course, is affecting real users by maybe increasing tail latencies through your load test, or causing an outright outage. It's also possible to just bring down everything in flames. And the way that you work around it is twofold, really. The first one is that you just be cautious and you always ramp up load slowly and over time, so that any negative effects of extra traffic can be spotted early and the test run can be either paused or stopped. You never want to go, the whole hog from the very beginning. It's very important to exercise caution, especially early on, and also to be seen to be exercising caution. And the second part is to have your production SLOs and KPIs monitored, and for those metrics to be readily available, both for people running those tests manually initially, and also programmatically, so that later on you can plug into those metrics from the load tests themselves to be able to run them without human oversight. We might not be able to do 100% coverage. That's another common objection that pops up, and it's usually a variation of, are we going to load test our payment processing or physical stock allocation? No, the answer is no. There will always be parts of the system that you will not want to exercise or not be able to exercise. But if you have a 10-step process and you test the first 9 steps and then skip out the last one, you've still gained a lot of confidence and got a lot of value out of the testing process. And this 100% coverage point is often related to load testing third-party services and dependencies. This also has to be done on a case-by-case basis, but a simple solution for this is to use a mock instead. Cost, last and kind of the least important concern in my opinion, my experience. Yes, you will be using additional resources by adding that extra traffic, both to generate it and to be able to process it. Ultimately, it's a case-by-case call. You might have to put a rough estimation together. At the end of the day, it's up to the company to decide whether it's worth it or not. But what I like to point out here is that any argument against production load testing based on cost would also work against doing other kinds of testing, like spending time on writing unit tests, or even for paying for non-production environments. And most companies probably still do and have both of those. So far, everything I've spoken about has been about technical mitigations around common concerns, but the social side of this is just as important. You really need to talk to people, publicize your production load testing initiative across the entire company, talk to other teams that may want to know or be affected by this extra production traffic, and teams outside of core engineering as well, like analytics, data, marketing, frontline customer support, and so on. So next, let's look at some prerequisites that we need to have in place before we consider production load testing. So as I mentioned earlier, we absolutely need the ability to monitor our production SLOs and KPIs in real time. And we need to be able to see at a glance when we're getting close to breaching one of them. We also need to be able to decide what our tolerances are. So that essentially is what expresses our condition for stopping or pausing a test. For example, if your response time SLO is P95 of, say, 500 milliseconds calculated over a sliding 5-minute window, then you need to decide if you're okay with breaching that maybe for a consecutive 10-minute period. And if the typical value is somewhere around 300, how close to that 500 are you happy to get before you might want to stop the test? The key here again is that as an operator, whether I'm a human or an automated process, I can very easily decide whether the test should continue or be stopped in real time. If you don't have this, then load testing in production is simply too dangerous. In a similar vein, you should have monitoring across all layers of your system, but given that you're probably running a complex production system, you probably have that in place already. You really need to be able to distinguish between synthetic and real traffic. So for example, say you're using Datadog, you should be able to plot a chart which shows you all requests to your system and then be able to split that by traffic from real users versus traffic from your load test. The way you do that is through tagging your metrics. The exact mechanics will depend on how exactly you're tracking those metrics, but it should be possible. And finally, this goes without saying, but you should be able to stop your load test almost instantly when needed. And this is some hard-won experience right here. We were running tests and we did have the ability to stop them, but just not quite instantly, but over about a period of 5 to 10 minutes, which that 5 to 10 minutes can feel like a very, very long time when you're seeing, error rate climbing up on production. So make sure that you can stop your tests almost instantly. So what might our roadmap for going from 0 to production load testing look like in practical terms? So let's say that your starting point is that you are not running not just any load test in production, but no load tests whatsoever even on any individual components in your system. So again, the overall idea here is that you will want to iterate and communicate your progress to other teams and anyone who might be interested. So the first thing, of course, that we will want to do is pick our load testing tooling. We already covered that and the evaluation criteria that you can use. In parallel, as that's being set up, you will want to start talking to relevant people and relevant teams. So usually a project like this would be championed by an SRE team or its equivalent in your company. Obviously, we also want to include any developer teams in charge of any services or any components which are going to be hit with that extra load. We want to let data and analytics teams also know well in advance to get as much feedback from them as possible, because it's very likely that some data pipelines or analytic pipelines are going to be affected by this extra traffic. Someone from marketing and product should also be included, if for no other reason than to let them know how seriously you take the reliability of your production system. In my experience in general, pretty much no one does not want to know that you're working towards being able to run load tests in production. That ability to be able to say we can handle traffic spikes at any moment in time in production is very easy to understand by anyone in the company, and it's something that obviously carries quite a lot of value, and it also just sounds cool. Another thing that you will want to do is to set up a situation room or an updates room in Slack or whatever real-time communication platform of choice is at your company. So this will be used for updates on the project itself and also for real-time updates as load tests are being planned, being run, or complete. Your next step, a very important step, will be to gather data. So we will need to understand the load patterns on the production system and also usage patterns from users or clients. What are the most common user journeys through the system? What does traffic look like? Are there daily or weekly peaks, for example? And this will inform testing scenarios that you will be writing. So to start with, it's best to pick something very simple and then expand your coverage with time. And it will also inform when you will want to run your first few tests. And the general idea here is that you want to stay on the safe side. So your first few tests will exercise a small part of the system during off-peak hours. This will also help you make sure that synthetic traffic is realistic and exercises the system in a realistic manner. So you hit the same endpoints in the same general sequence and with your synthetic traffic as with real traffic, and that you ramp it up as real traffic. Next is you'll want to start putting together a new set of dashboards, which a human operator can use when running the first few production load tests to make that decision of whether to continue or maybe stop. And you want to be able to do it at a glance. And as all this information is being put together, you will also want to start writing a run book for running these load tests. So the information it needs to contain is how you prepare the test, how you do a dry run, how you do a full run. This is where you go to watch key metrics. These are the thresholds for stopping the test early. This is how you prepare test data if you need to do that. This is how you clean up, etc., etc. This is very important because it will serve as a basis for automation later. And then finally, you have your scenarios ready to go. You have a time window for your first test. You've got your monitoring set up. Pick a modest amount of traffic to start with and run that test. Announce it first. So do announce it first, at least a day in advance, to give anyone who might have a reason for you not to run it, get in touch and ask you to hold off. But once you're ready, just run that test. If everything goes okay, run it again at higher level of load, and then do it again and do it again. At this point, it should not feel dangerous at all, because if nothing else, you will not be adding too much load all at once. And if everything goes well, eventually you will arrive at a point where, for example, you're running with extra 20% of production load and things just work. And at this point, it's very important to celebrate. Running production load tests is hugely important, so spread the good news and be proud of it. You might want to tackle 4 p.m. deploys on a Friday next, perhaps, if things go well here. So, in conclusion, I hope that having heard this talk, you will feel like you have more clarity on what it takes to run load tests in production, and an understanding that it really isn't that hard. It takes time, it takes teamwork, it takes a perspective shift, but it's very doable. And I'm hoping that you will want to give it a go and get to experience just how fun it is and how great it feels to have that confidence that your production system can handle extra traffic spike at any point without breaking a sweat. So I'd love to talk to anyone who might have any questions or share experiences with people that are already running production load tests. There's a Q&A after this talk, but also please feel free to either email me or message me on Twitter. Thank you.
Well, thank you very much, Hassy. That was brilliant. I really enjoyed the talk. It's quite insightful to like hear load testing set out so well. We don't, it's one of those areas of SRE that is often, I think, missed, and people don't understand as much because we're busy building the systems at scale, but we don't think about how to test it and ensure it. So it's really nice to hear it laid out as to why test, etc. Why testing in production is a really interesting question, and I think you answered it quite well. But Dr. Pillbot in the chat had a very similar question to me, which is, if you're building these highly available systems, are you suggesting that we should load test them at 100%? Normally we build them with a set of redundancy, such as a 3-node cluster with one spare that you don't use up, so that you have that overhead and that headroom to be able to survive production changes in traffic. Are you suggesting that we should be load testing all the way up to 100%, or just to a smaller degree?
That's a great question. I'm definitely suggesting that you load test those systems, because otherwise, how do you know that that extra redundancy that you've got built in will actually work for serving that extra traffic? I think for this specific question, it's quite important to define more precisely what redundancy means in the context of that question, and how that load is measured too. So if that was a conversation that I would find myself having with someone that I was trying to convince to load test in production, at this point I would probably ask a question back to say, how do you know that that extra node that you think will be able to help you handle that extra 33% of traffic is actually able to do that, as opposed to that node being there to be able to take existing levels of traffic if another node fails.
Yeah.
So I hope that makes sense.
Yeah, no, it does. I think like the way you describe it almost feels like you're using the load testing to discover where the bottlenecks are, because you can theorize where you think they are. If I add an extra node, I'll gain an extra 1/n capacity, but the bottleneck might have shifted as you do that. Is that right?
Absolutely, yeah. And there's a difference between availability and performance. Let's say if we define performance as your P95 response time, say. So redundancy, and let's say redundancy is extra nodes in a cluster, that helps us with availability. That is, if a node goes down, then the workload can still be processed. But there are some fundamental laws, like Amdahl's law, for example, that says that if you throw extra nodes into a cluster, that doesn't mean that your performance, defined by response time, say, will necessarily reduce because of fundamental bottlenecks in your algorithms or in how data is partitioned, etc., etc.
Yeah, no, that completely makes sense. You've talked about evolutionary architecture in your talk. Can you describe what you mean by that, and how this helps with evolutionary architecture?
Yeah, so this question is great because it ties in directly into the first question. Evolutionary Architecture is a book which was published by O'Reilly a few years ago now. I think the title might be something like Building Evolutionary Architectures. Great read, recommended to everybody. The main problem that the book looks at is, given a complex system with a very high rate of change, what are some of the ways that we can protect some of those important architectural characteristics of that system, like performance or reliability? And where the book goes is it looks to evolutionary theory and the idea of fitness functions, which in evolutionary theory are things or environmental characteristics that force organisms to adapt to certain conditions and evolve in a certain way. So in this specific case, if an engineering team knows that there's a production load test which is scheduled to run every single week, that changes both the behaviors of that engineering team, in terms of how code is written, how it's deployed, how it's monitored, but it also means that any deficiencies are brought to light very quickly. You will literally see important metrics drop as your load test runs. And then I think, which is also really important, unfortunately, very often performance gets sort of, pushed back towards the bottom of the backlog on a typical team. If you have something like production load testing as an accepted practice inside a company or an organization, any deficiency that a load test highlights becomes much easier to then prioritize to be fixed, just because those production load tests are an accepted practice, and anything that they highlight is expected to be fixed.
That makes a lot of sense. And I think summarizing a bunch of questions, and I'll come back to the individual ones in a bit, but like there's questions and discussion in the sidebar about, should people even have a staging service or staging server? Should you be doing your load tests in staging, or should you not have one at all? Like, where do you sit on that world? How valuable do you think staging environments are, and how much confidence do they give us in the reliability, performance, and other, characteristics of our software?
Yeah, the whole discussion about having staging environments or not, I think, could be its own conference almost. It'd definitely take a few days to sort through everything. In the context of load testing specifically, I think staging or non-prod environments can be very, very useful for testing components. And those components, they could be individual microservices. They could be small constellations of microservices, maybe that handle the same business domain or related bits of business domain. But a complex system's properties will always, the most interesting properties will always be emergent, which means that you do need to have everything working together, and you need to test everything working together as well. And, if a team or if someone can truly replicate their production environment in a staging environment, then more power to them. For every single production system, non-trivial production system that I can think of, it's simply impossible.
And that's not just the replication of the environment, but the replication of the properties of the data and stuff like that. I assume it's not as simple as just do I have auto scaling, right?
Absolutely, yeah. It's even sort of if we go down to one of the, well, not the lowest, but one of the lower levels. Even the type of the EC2 instance that you run things on can have huge effects on the performance that you're seeing. So if you're not replicating that, if all you're doing is maybe redeploying something that sort of looks like production, if you squint at it from the right angle and kind of zoom out, far enough, you're not testing the real thing. And I think that's the bottom line.
I totally agree. It's a really interesting bit. I was converted a number of years ago to running functional tests in production by somebody and some of the talks, and I think it really echoes to me. I really agree with you. One of the things I was curious about, though, was, are there a set of precursors or prerequisites to being able to do this load testing at all? Like, do you need to be investing in organizations, in systems and platforms that do auto scaling, that do bulk management? If you're stuck on legacy on-premise tin, is this possible still, or do you think that you need to have those auto scaling properties of your system in place to be able to take advantage of this?
So that's a good question. I've never had the misfortune of working with a system that didn't have auto scaling built in. So that that might show the types of systems that I've worked on. I would still. So I'm a bit, I'd be sort of out of my area of experience here. I would say that I would lean towards a yes by default, but even bare metal on-prem is quite a different world. So I'd probably have to spend a lot more time thinking about what could go wrong before I attempted something like that. But do I think it's possible? No.
Right. Okay. Yeah. And do you think that it's only available if you've thought about load testing in production from the beginning, or can any code base be adapted to being tested in production? Do you need things to be there, or can you do it, bring it to any code base? Are you able to turn up to any client and say, here's how you do it, and make it happen?
Yeah, so with the caveat that we do have auto-scaling available for this question, I'd say any code base can be adapted. I think the key is to clear those certain prerequisites, around monitoring, around observability, around having auto-scaling and other kinds of auto-healing first, and then start small and build up your production load testing in layers. And obviously that has to, tie back to whether you think it's worth it or not. And you do have to build buy-in from your team and from the wider organization. But that, I think that is almost the more challenging part of this. Any engineering challenges can be overcome. As always, it kind of comes down to being able to work with people and people problems as opposed to technical problems.
And you talked a little bit about how to ensure that you don't load test destructive properties, that you mock out certain behaviors like charging cards and things on the back end. Does that bring with it any compliance issues around PCI or security compliance? Are there boundaries or barriers that you have to be aware of when you're considering load testing in production in more heavily regulated environments?
That's a good question. So I haven't come across any sort of showstoppers. Obviously, if that's something that's relevant to the specific situation, specific organization, then I would say defer to your domain expert in the company. So in general, I cannot think of sort of a scenario that I've come across where that would have prevented us from running production load tests.
Right.
You might have to, in that chain of calling that external service or making that destructive update, you can bring in that no op branch or that mock, a bit earlier, maybe, as opposed to a bit later. But there's always a way around it.
And I've seen James Abley asking in the chat, is there any issues with attempting to do this kind of load testing against JavaScript heavy websites or single page web applications that are done almost entirely in JavaScript? Does that become more difficult to test against? Is there mocks or systems or processes you can use that are easier with that system, or is it just REST APIs are the easiest and then JavaScript applications are horrendous for many reasons?
They are horrendous. That is one of the reasons. Absolutely. I agree. So there are two answers to this question, I suppose. One is that these days it's possible to do full browser load testing with things like AWS Lambda and Google Cloud Run. You can literally run hundreds or thousands of headless browsers in the cloud, which will have full client-side JavaScript evaluation. It's still quite expensive, but it's a lot more possible today than even 2 or 3 years ago when it was an absolute pain. The other side of that, I suppose, is in an ideal world, every endpoint and every API that client-side JavaScript calls is a nice RESTful or GraphQL API with proper API docs that you can very easily talk to from your load test scenarios. Not always the case. It can be a challenge, which mostly affects the time that it takes you to develop your load testing script.
How do you get around issues in production around things like security guards, like DDoS protection systems or content delivery networks or other systems that are there and would identify a load test as looking very much like malicious activity that they're designed to detect, stop and drop? Is there easy ways to get around that stuff in a way that doesn't help the bad guys as well or introduce vulnerabilities?
Easy ways? Not really, no. So the main one of the most important things to do is if you're running large scale load tests and you think you might trigger your DDoS protection system or your WAF, speak to the team who are in charge and they will be able to advise, on ways on how you might bypass it or temporarily disable it. That's one aspect of it. The other aspect is that running distributed load tests, and we have the luxury of doing it these days, you want to use as many public IPs as possible, essentially. And that's important for both, lessening the chances of triggering some kind of malicious activity protection. It can also be really important for making sure that the traffic is load balanced evenly. So depending on your load balancer configuration, even your load balancer type in AWS, if you have a small number of IPs that are hitting your system, your traffic could become, or it could get load balanced in a very uneven manner. So use a lot of IPs would be my go-to advice.
And we've heard a lot today from pretty much all the speakers about large, complex organizations in which you've got platform teams, you've got lots of microservices. How do you deal with the interconnectedness of platforms? You as a team might be interested in load testing the shopping basket functionality, but you might create in production issues on the underlying platform or on the database team or another team who aren't your team. How do you go around coordinating that work?
So it all comes down to communication, as most things do, I suppose, in engineering. That's why in the talk I was saying to leave plenty of time for production, load testing, planning, and implementation, because the way you do it is you start at the top. So if you've got a public endpoint, which is exercised by your client-side JavaScript, which is responsible for that shopping cart, you start there and you try to identify the first layer of teams and services that might be affected by that. And then you go and you speak to those teams. If you're in a platform team, it's very helpful to have, and this ties back to a discussion earlier today where we're talking about how platform teams these days should really try to build up this product mindset. So if you're a platform team and you have a newsletter or some kind of a public channel on Slack where people come to you and ask you questions, then that becomes a very good medium for publicizing your public load testing activities and for encouraging people to come to you with information, concerns, and worries. And this is how you identify kind of services and components that maybe aren't on that architecture diagram that every company has, but it's never up to date or very accurate.
That's great. So it's about being transparent, communicating with all those stakeholders out there and making sure they know what you're doing and have an opportunity to object. That's been brilliant. I've really enjoyed the talk. I've loved the questions and answers.
Thank
I have one final question for you, again, based on Reddit. Would you rather be load tested by 1,000 smart, tiny load testing services or one really big one?
Oh, God. That's an excellent question. That's a very difficult question, too. I really don't know. I think I would like to try both and see, which one is worse or which one feels better.
Great. Okay. Thank you very much. You've been really good. And thank you to you and all the speakers, of course.